Welcome to January 4th LeetCode Challenge, complement of base 10 integer. The complement of an integer is an integer when you get when you flip all the zeros to 1, all the ones to zeros in binary representation. For example, the integer 5 is 101 in binary, and its complement is 010, which is the integer 2. Given integer n, return its complement. So we have a number here, 5. This is actually the example given here, and the binary representation is 101. If we take a complement of that, which is 101, and which is 010, I should say, and then which is the base 10, which is an integer 2. For example, we're given the integer 7. The binary representation of the integer 7 is 111. Take the complement of that, which is 000, which is 0 in base 10. If we're given integer 10, 10, the binary number representation of 10 is 1010. The complement of that would be 0101, which is number 5 in base 10. Alright, here's our constraint. So how would we go about solving this? So there's a bunch of ways of doing this. The first one I thought of was using a bitwise XOR operation, so XOR masking. So basically, in order to do that, XOR, let's see, I'll give you an example. So say we're given number 100, right, which is the binary representation of, let's see, it is 2, 4, 6. It's 6, I hope. Yeah, binary representation of 1, 0, 0 is actually 6. No, wait, it's 4. It's 4. I'm actually gonna write that out. N equals 4. Binary representation is 100. So we want to take the complement of that, right? And that's gonna be basically 101, and that actually is equal to the base 10 digit number 3. So how do we get from 100 to 011? So what we could do is actually we could do what's called the XOR operator, XOR bitwise masking, XOR masking, which is basically we mask it with ones, and that's gonna give you 101. And that's basically it. We take the XOR operation between the number given and the length of it times by everything by 1. So a simple way to do that is initialize the mask to 0, and we keep flipping all the bits starting at 1, and then the least significant bit will reach the end of the number. So let's go with that idea. So the first thing we want to do is, what if n is equal to 0, right? If n is initially given to 0, so if not n, return 1. Because if it's 0 initially to begin with, we're just going to flip the bit because the binary representation of 0 is 0, and then if we take the complement of that, which will be 1, right? And the binary, and then the base 10 representation of 1 is 1. And that's our base case out of the way. Next thing we're going to do is develop our mask. So let's initialize mask to 0 for now. And we're going to have a number that's going to be, that's going to hold on to our current value. Let's call that temp. And that's going to be equal to n. The reason why we assign temp to n, because we don't want to manipulate n right away. We'll still need that number later down the line, because we're going to need that to do the XOR operation. So while temp is true, we're going to update our mask with the length of So this is basically we're doing a bitwise shift here of 1. So every time we have the mask equal to 0, we're just gonna shift. Every time we have temp equal to true equals 1, we just shift 1. So therefore we just make the size of number ones of binary, the length of binary representation of the mask to be the same size as our temp, and that's going to be shiftwise with 1. And then this, so once we have temp and then we have our mask, then we just do XOR operation. We actually just return our XOR operation, which is n XOR with our mask. Alright, let's submit this. Alright, there you go. That's the what's called the time complexity wise is a big O of n, because you would do a while loop each time, where n is the number of length of the bits. Space complexity is big O of constant space because you store everything inside variables. Alright. Is there another way to do this besides, if you're not familiar with XOR masking, what we could do is another approach could be just using a simple else loop factor. So likewise, similar. Let's see if we could do that. Yeah, it works. So I'm just gonna leave it there. There's another way of doing it, but there you go. Have a great day, guys.